Kia ora, I'm Eleanor. Thanks for joining me for this presentation, Whakawhanaungatanga using DNA, 23andMe. This talk is about how to find the matches at 23andMe who are most likely to share recent common ancestors with you. It's a follow-up to a 3-part series I created for Roots Tech Connect, held online during February 2021. The series is still available to view online for free. If you haven't watched the Roots Tech series yet, I recommend that you pause this video and watch the Roots Tech series first, or at least watch part 1, which explains the basics of DNA inheritance, why Māori may face extra challenges when using DNA test results to Whakawhanaungatanga, and how we can start to overcome those challenges. There's a link to the series in the description below. If you follow that link, you'll also find a link to a glossary for the kupu Māori words that I'll be using in this talk. If you want to just keep watching this talk for now, that's all good too. There will be a bit of repetition with some of the same info that's in the Roots Tech series and or the Whakawhanaungatanga using DNA, my heritage talk, available on this channel. If you have some questions at the end of this 23andMe talk, you may find the answers in one of the Roots Tech talks or the My Heritage talk. Depending on your questions, you might also want to watch my talk at Legacy Family Tree webinars. This talk focuses on how Y-DNA test results can provide a very helpful complement to DNA test results from 23andMe. This talk was free to view when it first aired. It was free to view for 1 week. That was in June 2021. But it now requires a subscription to view. Subscriptions are frequently on sale, so look out for a special if you don't yet have a subscription. Before we go further, I want to emphasize that this talk is not about me pushing DNA testing as a way to prove you're Māori. Although for those of you who aren't sure if you're Māori or not, because you don't know your whānau or whakapapa, perhaps because you or your parents were adopted, or your grandparents may have been adopted, or great-grandparents, DNA testing may be able to help. This talk also isn't about privileging DNA testing over going back to your marae and learning about your whakapapa from your kuia and kaumātua if that's an option for you. Nor is this talk about convincing people to DNA test. Nor is it about supporting theories or laws based on blood quantum. These are all common and understandably important concerns when the topic of Māori DNA testing is raised. I won't be discussing them further in this talk, however. If you'd like to know more about these and other concerns that DNA testing may raise for Māori, you'll find a link to an article on that topic in both the Roots Tech series handout and the Legacy Family Tree webinars handout. So what are we going to be looking at in this talk? Well, we're going to be looking at using DNA testing as a tool for Whakawhanaungatanga. DNA test results can help us to make connections with whanaunga and learn more about ourselves, our whānau and our whakapapa, and of course that includes learning about our non-Māori ancestors and relatives as well. I'm going to assume you've watched at least part 1 of the Roots Tech series, and you know that because of the amazing history of Pacific migration, if you have one or more Māori great-great-grandparents, the matches who appear at the top of your 23andMe match list might not actually share recent common ancestors with you. You also know that instead of having a smallish number of close matches who share lots of DNA with you, you may have hundreds or even thousands of so-called close matches. Even though these matches do share lots of DNA with you, most of them won't actually share recent common ancestors with you. To find the matches who are most likely to share recent common ancestors, you'll need to sort through your match list. If you've watched the Roots Tech series, you already know the matches to look out for. They'll be the ones who share many large segments of DNA with you. At 23andMe, you want to look out for matches who share at least one segment of 30 centimorgans or more, and at least a few other 20 centimorgan or longer segments as well. It's a bit of work, but if you follow the process, at the end you'll have a customized list of priority matches. These people or matches would be at the top of your match list if the DNA match lists were built for people from communities whose DNA results are impacted by historical founder effect and endogamy. Let's look now at how 23andMe can help us to whakawhanaungatanga. First off, 23andMe can help us because you'll have matches who have only tested at 23andMe and are not in any other database. If you want the maximum chance to connect with known and or unknown whānau, you want to be in all the top 4 DNA testing databases. That is 23andMe, Ancestry, Family Tree DNA, and MyHeritage. At 23andMe, the segment data is available for all matches who have opted into sharing, and unlike any other database, you can directly compare your matches to each other, so you can see both how much DNA you share with your matches and how much DNA they share with each other. MyHeritage does offer something similar, but you can't see the segment data for how your matches are matching each other. The process of finding matches at 23andMe who share long segments of DNA with you isn't that easy because you can't just sort your match list by longer segment, unfortunately. So that is a bit of a challenge. But something that is another positive is that 23andMe offers Y-DNA and mitochondrial haplogroups. Haplogroups are pretty much like a genetic clan or iwi for your direct paternal and direct maternal lines. The information can be useful for ruling in or out a connection on these lines. Just a quick note on terms. Each DNA testing company calls the longest segment something slightly different. You've already heard me use longest block if you watched part 2 of the Roots Text series when I was talking about family tree DNA. Longest segment in part 3 of the Roots Text series while talking about ancestry. Largest segment in the MyHeritage talk on this channel. And now at 23andMe, it's called genetic distance. It can be confusing to have all these different terms, but just so you know for now, in this context, all of these terms do mean pretty much the same thing. Now, let's take a look at the process at 23andMe for finding the matches who are most likely to share recent common ancestors with you. One easy way to get started is by sorting your match list by percent related. In your DNA match list, 23andMe shows you the percentage of DNA you share with a match as the default. So when you start scrolling through your match list, what you want to do is look for matches who share a high percentage of DNA with you, but a low number of segments. Next, we want to view the segment data. This is so we can get to see what is the size of all the segments. Next, we filter out all the small segments of DNA to get an adjusted total. That only includes the large segments of DNA. Then we put that new total into the Shed Centimorgan tool at DNA Painter to generate more accurate relationship predictions. With these new relationship predictions, we are now in a better position to start looking at how we are related to the DNA matches. Lastly, we also have the option to work out the average segment. Working out the average segment can be a quick way of gauging whether a match is likely to share a recent common ancestor or not. Let's look now at some examples from 23andMe. Please keep in mind that the way that information is presented on DNA testing companies' websites is updated from time to time. By the time you're watching this video, your results may look a bit different from the images that you're going to see here. Just depends when you're watching the video and when the latest update was. All matches' names are fictional to protect the privacy of the tester and matches. At 23andMe, there are a few ways to work through your match list, called DNA relatives. The method I'm going to show you first does not require using spreadsheets. Start by ordering your DNA match list by percent related. You can then scroll down through your match list. You're looking for matches with whom you share a high percent of DNA, but a low number of segments. Let's look at a couple of examples. These two matches share a similar amount of DNA with the tester, around 2.8%. For the match at the top, who is predicted to be a first cousin twice removed, the total shared DNA is spread across 27 segments. The second match, who is an estimated second cousin once removed, shares a little less DNA with the tester, but this DNA is spread across only 6 segments. This means all the segments shared with the second match are going to have to be pretty long. Now, from this information alone, we can predict which match most likely shares a recent common ancestor. It's this one. Because the total percentage of DNA shared is high, but it is spread across only a few segments. The next step, once you've found a match like this, is to scroll right down to the bottom of the page and click on the Advanced DNA Comparison feature. This will allow you to compare the match of interest in a chromosome browser, if the matches have opted in to sharing their segment data. I recommend you click on the Advanced DNA Comparison link, give it a right click, and then open the page in another tab or window so you don't lose your progress that you've made scrolling through your DNA relatives list. Now, in the Advanced DNA Comparison page, you can compare yourself or another match to up to 5 other matches at a time. You need to type the name of the match you're wanting to compare yourself to in this box, and then choose the name from the list below. Remember these two matches? Let's go compare our tester in the chromosome browser to these two matches. Viewed like this, it's easy to see the difference between the match who shares 6 segments, shown here in purple, and the match who shares 27 segments, shown here in orange. Now, I just called this the chromosome browser. This is the Advanced DNA Comparison page, so that's what it's called at 23andMe when you're looking for it, but what we're seeing is the results in a chromosome browser. So just like at Family Tree DNA and MyHeritage, you can hover over the segments to see how long they are. The key information will be shown in CM, Centimorgans. CM stands for Centimorgans. It's a measure of how much DNA you share with a match. What we want to do is scroll right to the bottom of the chromosome browser to see the detailed segment data. You'll need to scroll through this list yourself to find the longest segment for each match. There is no way to organize the list by longest segment. And 23andMe doesn't call the column longest segment. The column you're looking for here is called genetic distance. This is the segment data for the purple match. You can see the tester and match share at least one segment, 30 centimorgans or longer, and a couple of segments, 20 centimorgans or longer. Once again, this is what we expect for a tester and match who share a recent common ancestor. Now, I'd refer to this match as a priority match because you will almost definitely share a recent common ancestor with a match like this. And even if neither you nor your match know your whakapapa, you have a pretty good chance of working out how you're related if you have other similar matches, either in the 23andMe database or in other databases. with people from the same whānau who do know their whakapapa and are willing to help you to work out your connections to each other and to them. Working out the connections will require sharing a whakapapa and most likely also asking other known whānau members to take a DNA test. Now, you might have spotted that the bottom row on this table also shows the amount of DNA shared on the X chromosome. Ancestry and MyHeritage don't show us how much DNA we share with our matches on the X chromosome, but 23andMe and Family Tree DNA do. When we're looking at how many large segments we share with a match, we don't want to include the X chromosome. The inheritance pattern of the X chromosome is different. It can be helpful to learn more about it, but the main thing to remember for now is that we won't include how much DNA we share on the X chromosome when we're looking at whether a match shares large segments or any segments of DNA with us. Now let's look at the orange match. This was the predicted first cousin twice removed who shares 2.85% over 27 segments. Now, as you can tell, I had to shrink the screenshot to get all the segments on the slide, and you probably can't read any of them. The longest segment shared with the match is 15 centimorgans. If we zoom in, we can see that a bit more easily. Now, what this tells us is that the most recent common ancestor for the tester and match probably lived quite a long time ago and was several generations back in the whakapapa. This match, therefore, is not likely to be a first cousin twice removed, despite that being what the company estimates, based on the total. To get a better idea of how of what the most recent relationship is between the tester and match, you can copy and paste all the segment data info into the individual match filter at DNA Painter and choose to filter out all the segments under 15 centimorgans to get an adjusted total. Remember, if you're going to adjust the total and there's a match on the X chromosome, you want to subtract that as well. Fortunately, Johnny Pearl has created this really handy tool, individual match filter, and you'll find it at his website, dnapainter.com. All we need to do is click on this pale coloured box to go to the tool. I've given the full steps of how to use this tool in part 2 of the Roots Tech series, the Family Tree DNA talk. So I'm not going to go through all the steps here, but I do want to highlight that if you use this tool with 23andMe or Family Tree DNA data, you do want to tick this box so that any match on the X chromosome is subtracted along with all the other segments that are under 15. So let's just jump now to the end result. For the match sharing 2.85% over 27 segments, the total that we have left once we've removed all the segments under 15 is just 15 centimorgans, or 0.2%. So the total's been reduced by over 2% when we remove all the small segments. Now from here, we can put this adjusted total into the shared Centimorgan tool at the same website, DNA Painter, to generate adjusted relationship predictions. Now, if you didn't know, DNA Painter is a free website. You can pay a subscription to get access to other tools and features, but there are many tools available for free, including the Shed Centimorgan tool and the previous tool we looked at, Individual Match Filter. So just a reminder, when you're using the Shed Centimorgan tool, it is not designed to be used with matches that you know share multiple common ancestors and therefore multiple relationships with you. Because of the history of founder effect and endogamy, your Māori and Polynesian matches will share multiple different common ancestors on different lines. So when we get the relationship predictions, we do need to be mindful that they might not be correct, none of them. None of them may be correct for the relationship, the most recent relationship. But in this example, we're using an adjusted total based on only the segments 15 centimorgans and up. So the predicted relationships for Māori and Polynesian matches are likely to be more accurate. So to use the tool, we just need to click on the green box, and we enter the adjusted total, which in this case is 15. And if we were on the website, we'd be scrolling down and we'd see this. The predicted relationships when a match shares 15 centimorgans. So there is a lot of info on this slide, and what the info is telling us is that there is a 60% chance that the tester and match are related in one of the ways listed in the top box. There is a 16% chance that the tester and match are related in one of these ways. An 8% chance that the match is related in one of these ways. And only a 1% chance of the tester and match being related in one of these ways. Now, first cousin twice removed, which was the prediction from 23andMe, is listed as an option. However, there is a dagger symbol beside this relationship, and what that is letting us know is that even though it's a possibility that this is the most recent known relationship, it's very, very unlikely. And it's the same for one of the other relationship options, first cousin 3 times removed. So I'm not going to go into all the detail why these matches, this relationship is even suggested. You can read more about why on the DNA Painter website. There are links there that are going to take you to other pages where you can read more in detail. But the main thing to remember here today is just focus on the relationship options that don't have the dagger by them. Now, if you scroll a bit further down the page, you can see all the predicted relationships in this chart view. When you and a match share 15 centimorgans, there are many possibilities. If we go back and compare the estimated relationships from 23andMe on the left with those from the Shared Centimorgan tool on the right, you can see there's a difference in the predicted relationships. 23andMe lists just one predicted relationship. In this example, it's a first cousin twice removed. But what we can do to get an idea of the other possible relationships at when you're sharing 2.85% is to put that total into the same tool, Shared Centimorgan tool, and we can bring that up. So the main takeaway here from this slide is that the close relationship that the close relationship that 23andMe predicted, first cousin twice removed, is not possible when we remove all the small segments and use the adjusted total of 15 centimorgans. Many of the other close relationships are also not possible. For example, half great-great-aunt or uncle, niece or nephew, second cousin, half first cousin once removed. None of these relationships are possible when the adjusted total is brought down to 15. There are other relationships that aren't possible, such as great-great-aunt or uncle, half great-aunt or uncle, half first cousin once removed, and also half great niece nephew or great great niece and nephew. So let's zoom in here to see all the predicted relationships that are possible when you share 15 centimorgans at the Shared Centimorgan tool. The closest predicted relationship is a half first cousin. But there's only a 1% chance that this relationship is correct. This match is not known to the tester and is from a completely different iwi. They're not neighbouring iwi at all. The tester and match have both had many of their whānau member's DNA test, and there's no question about the whakapapa. The DNA test results support the known whakapapa. So what this means is that the most recent common ancestors between the tester and match probably quite far back in the whakapapa, and it's possible that actually none of these relationships that are shown in this chart reflect the most recent relationship, and this chart only goes to 8th cousins, which is the relationship if you share 7 times great grandparents. So that's great 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 grandparents. That's 9 generations back. And by looking at matches that we have to people from completely different Eastern Polynesian, even Western Polynesian islands, we can see that we share similar matches to them. It's a similar amount of DNA. And of course, the most recent known ancestors for most of those matches would have lived 800 to 1,000 years ago. So that gives you an idea of how far back the most recent ancestors could be. Most people don't know their whakapapa on every ancestral line back 800 years. Some people are fortunate to know much further back on some of their lines, but typically not on all of their lines. So the chances of being able to find who the most recent common ancestors are for this match are very slim if you don't know your whakapapa. And even if you do know your whakapapa, chances are you don't know it this many generations back on all your different lines. And if you have multiple Māori lines, it would be hard to know who this DNA comes from, because it could be some of the DNA, some of the segments are coming from one ancestor and some are from another ancestor. So all that to say, this is why these kinds of matches aren't considered priority matches, particularly for people who have DNA tested to find unknown whānau and whakapapa. It's just so hard to work out your connections. Okay, so let's move on. And this is just another option if you don't want to be scrolling through looking for your matches who share a high percentage of shared DNA but a low number of segments. If you're comfortable with using spreadsheets, or at least you want to have a go, you have this option to download the data. It's on your DNA relatives page. You just scroll down to the blue button, click on this blue button. You're going to have a file downloaded to your computer or tablet, laptop, phone, depending on the capability of your phone. You might be able to do it there. I'd find it pretty tricky myself. You'll be able to open the spreadsheet file in a program such as Excel or Google Sheets. And when you have that file, you can look for the genetic distance column. That's this one here. You can search through the spreadsheet for matches with whom you share a genetic distance of 30 or more. So that's the equivalent to searching through at other websites looking for matches who share a longer segment of 30 centimorgans or more. And then once you find those matches, if you want to, you can go back to the website and look at the advanced DNA comparison page to see how you, all the different segments that you share with that match, and compare the match to other DNA matches that you have. Or you can look in your segment data here as well. And as you work through either your DNA relatives list or on the website or the spreadsheet, I recommend it's a good idea to take notes, so you're only going through this process once, because as you can tell, it's pretty time consuming. Now, before I end this talk, let's just look at how to calculate the average segment. Calculating the average segment is another way to get a sense of whether a match shares a recent common ancestor with you or not. You'll need to be on the advanced DNA comparison page or in the spreadsheet to get the info you need. I'm going to show you how to find the info when you're on the advanced DNA comparison page. You're going to need the total centimorgan and the number of segments, which you can find here. And you're also going to need the longest segment. You'll need to scroll down this page to get the detailed segment data, and then scroll here to find the longest segment. So let's do the maths now using this example. We have a total of 212 centimorgans. We have a longest segment of 15 centimorgans that we're going to subtract. This leaves 197 centimorgans. Next, we need to divide 197 by the number of segments, less 1. We have 27 segments. So we're going to divide 197 by 26, and this will give us an average segment of 8 centimorgans. Now this is quite a short average segment, even though the total shared DNA of 212 centimorgans is quite high, 2.85%. We know from looking at the segment data it's made up of mostly small segments, which is why we get this quite short average segment. I've already discussed that it's unlikely that this match shares a recent common ancestor. The most recent common ancestor could be more than 9 generations back in time. And most of your Māori and Polynesian matches will share short average segments, because out of the hundreds and thousands, there will not be that many who actually share recent common ancestors with you. Remember, if you're going to do the maths to calculate the average segment and there's a match on the X chromosome, you do need to subtract that as well. And if you've watched the third part of the Roots Text series, or the MyHeritage talk, you'll know that at Ancestry I recommend looking for matches who share a longest segment of 30 centimorgans or more. And you'll know that this 30 centimorgan minimum longest segment comes from the research of Kalani Mondoi, admin of the Polynesian project at Family Tree DNA, and the Polynesian DNA Facebook group. In addition, I suggest prioritising not only the matches who share a longest segment of 30 centimorgans, but specifically the matches who share a longer segment of 30 centimorgans and a minimum average segment of 11, and also a total of 100 centimorgans. Now the average segment minimum, that research comes from Leila Pearl Larkin initially. I've put a link to her most recent talk on this, which was at Roots Tech Connect. Well, the most recent free, accessible version of her talk. It's a 2-part series, and you'll see in that research that matches who have an average segment of less than 18 centimorgans are typically impacted or come from a community with this history of founder effect and endogamy. So, but this 11 centimorgan minimum average segment, that comes from research looking at Māori and Polynesian matches. So for 23andMe, I suggest you use the same thresholds. And at MyHeritage, I suggest slightly higher thresholds. That's to account for the process of imputation at MyHeritage. I haven't included thresholds here for Family Tree DNA because there's been a shake-up of the algorithms used there, and I haven't had a chance to reassess those results. You can watch part 2 of the Roots Text series to get some ideas for now as to how to evaluate your matches at Family Tree DNA. You definitely want to look for matches who share at least one 30 centimorgan or larger segment, and plus a few other 20 centimorgan or larger segments. We're almost at the end of this talk and we've covered a lot, so let's just now recap the process at 23andMe. Currently, if you have one or more Māori or Polynesian great-great-grandparents, you will probably need to do quite a lot of scrolling at 23andMe in order to identify the matches who share recent common ancestors with you. For Māori or Polynesian matches, I suggest removing segments under 15 centimorgans, recalculating the total, and then using the Shed Centimorgan tool to generate new, more accurate relationship predictions. As an additional or alternative workaround, you can calculate the average segment. Remember to remove the amount of DNA shared on the X chromosome, if there is any. I recommend you add notes to your match list at 23andMe or offline as you go, so you're only going through this process once for each match. You can upload a copy of your downloaded raw data file from 23andMe to Family Tree DNA and MyHeritage, so you get to be in those databases as well. You won't lose the data from 23andMe, you just download a copy, and you can upload it for free to Family Tree DNA and MyHeritage to get a list of DNA matches. Now, currently at 23andMe, there's probably the least number of Māori testers out of the top 4 databases. It is very expensive for us in Aotearoa, New Zealand, to test at 23andMe, particularly because of the high cost of, well, because the price includes a return courier with FedEx, but that does make it a really quick test to order, and because it's fairly swiftly returned to the States, you do tend to get your results quite quickly. But depending on the research you're wanting to do, you may also want to test it at Ancestry as well, because it has the largest database for Māori matches, and you can't upload there. But wherever you test or upload your raw data files, do be sure to check that you're comfortable with the terms of service. And as you work through your DNA match list at 23andMe, I just, a final word to say, prioritize your research on matches who share a larger segment of 30 centimorgans or more and an average of 11 centimorgans or more, because these are the matches who are most likely to share recent common ancestors with you, which means, particularly if you don't know your whānau or whakapapa, these are the matches who you're most likely to be able to work out your connections to. Wherever you DNA test or transfer your results to, remember that segment length matters. I can't 100% guarantee that you'll share a recent common ancestor with all your priority matches, but they are the matches who will most likely share recent common ancestors with you. I'm also not saying to ignore the matches who only share small segments or small average or a small total of DNA, but for most of them, it will be much more difficult to work out the common ancestors. So it's just, something to keep in mind. If particularly if you have DNA tested to find your whānau and whakapapa. Of course, finding the priority matches is only one step in the research process. There are others as well. Step 1 involves carefully looking at your ethnicity estimate and the ethnicity estimate of your match, because the higher your percentage of Polynesian DNA, which won't actually be called Polynesian DNA at 23andMe, it will be, at the moment, it's referred to as Austronesian and Filipino DNA, and also Melanesian DNA. The higher that percentage, then that means the more Māori or Polynesian ancestral lines that you have, the more tupuna that you have who are Māori, and the more that you have, the more that your DNA test results are likely to be impacted by this history of founder effect and endogamy. And so the more closely, I suggest that you follow this alternative guide. Step 3 is important because, as we saw in part 1 of the Roots Tech talk, and also in the Big Y talk at Legacy Family Tree webinars, The standard tools for grouping matches typically won't help to separate your Māori or Polynesian matches into family groups. Step 4 is important because DNA test results don't stand alone. We still need to do whakapapa or other traditional genealogy research to work out how we are related to our DNA matches. Step 5 will help you with your research, but it's important to never pressure anyone to take a DNA test and to make sure that anyone who you're asking to DNA test is fully aware of the risks involved. I touched on step 6 in part 2 of the Roots Tech series, the Family Tree DNA webinar, Family Tree DNA talk, and I talked about Y-DNA in depth in the Big Y talk at Legacy Family Tree webinars. I've put a link to those talks in the description below. Lastly, we can all learn so much more from our DNA test results when we collaborate with our matches. So once you've done the research that you can do independently, I encourage you to reach out to your DNA matches. But you need to do this with some sensitivity because many people DNA test and not aware that their matches can use the information to find unknown whānau or whakapapa. And, so we need to have some empathy and understanding, both for those who are looking for their whānau and whakapapa and also for the people who you're reaching out to, your DNA matches, who might not be aware that whānau or their whanaunga were missing, are unknown to them, and how DNA matching can be used to connect. Of course, if surprise matches reach out to you, I do hope that they'll be supported to connect with their whānau and whakapapa, but I understand that that's not always an easy process. If you've already DNA tested, you are welcome to join us at Te Ira Tangata Māori DNA on Facebook or at Te Ira Tangata Māori DNA Family Tree DNA Project. Of course, you will have need to already transfer your DNA test results to Family Tree DNA or Test Direct if you want to be in that part of that group project. You may also want to join some of the other specialist DNA help groups on Facebook, and I put some links in the description below, and there are more links on the Roots Tech webinars handout and the Legacy Family Tree webinars handout. One example of a group that you can join if you haven't DNA tested yet but you're interested in learning more is the Polynesian DNA Facebook group. So if you're interested in any other resources for learning more about the impact of founder effect and endogamy on your DNA test results and what other strategies you can try to get the most out of your DNA results, you'll find some links in those handouts as well. So there's lots more many more resources that you can learn from, and I hope you'll find some of those ones useful as well. Thank you for joining me for this talk. I hope you found it useful. Best wishes with your research. And thanks to everyone who's helped put this presentation together. There's quite a few people working behind the scenes, many people. So thank you to you all. Ngā mihi kia koutou katoa.